Chapter 13, Randomness and Probability. If you open your packets, we're going to go ahead and do some of these notes here. So the first thing to understand is that behavior is random. We call this a random phenomenon. And because behavior is random, we look for probability to be a long-term aspect. I gave the example in class. This is 2022. The Astros have just won the World Series. And in the 2022-2023 season, we had Jose Altuve have a 300 batting average. A 300 batting average means 30% of the time he is hitting the ball and he is making it safely to base. By the way, that's good in the major leagues. Even though 30% might not seem like a lot, they're facing 100-mile-an-hour pitches. They're going fastball, it's going curve, slider, all kinds of different pitches. So, and this is without it getting caught, without it getting thrown out. They're safely on base. So, before the World Series, there were 4 games with the New York Yankees. And game one, Jose Altuve had a 0%. 2, also 0%. 3, also 0%. He hit nothing, absolutely nothing. But when it came to game 4, he hit 80%. The total average with all of his was an 18.8%. Now, this was definitely lower than what he usually does. It's lower than his average and then lower, obviously, than his season average. But if I were to look at just these 3 games, I'd say, man, he's not a very good player. Even if I looked at the 4 games, this here is much lower than what would be considered a good major league player. However, instead, I looked at the more than 160 games in the whole season to say he is a really strong player because probability is long-term. And you have to write that on all your FRQs, making sure you demonstrate that it's a long-term problem. So something that's more long-term than just rolling a dice, if I roll the die one time, I have a 1/6 probability for it to hit any particular number. But if I rolled it 60 times, then I would expect, this is what I expect to see, each one to get 10 and so forth and so on, right? Now, it might not get 10 exactly. 1 might get 10, 2 might get 9, 3 I might get 11 times, I might roll a 4, 12 times I might roll a 5, 8 times, and let's say I roll a 6, 10 times, total of 60 times. But if you can tell, all of these are going to be within some sort of really close to 10. I mean, it could be as close to as 7 and high as 13. But it's going to be all around 10. You are not going to get something you're not going to get 1 or no ones. You're going to get something because I've rolled it 60 times, and that's enough times to be able to start to get close to the probability. That's what this is, and so here's this definition. And you need to make sure you see large repetition. So you could say many, many times. You have to make sure, again, you do that in the FRQ. You have to describe it, that this happens many, many times. All right, here's a little couple definitions. A set of all possible events is called the sample space of the event. So, for example, if I said roll a die and observe what it lands on, the sample space would be everything that could happen, which is 1, 2, 3, 4, 5, 6. An event is a set of outcomes from the sample space. So each one of these are the separate events that could happen. So there's 6 events. So if I'm flipping 3 coins, let's say I get tails, heads, tails. This is one event from a sample space. If I flip 3 coins and I get 2 tails, that could be tails, heads, tails, 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 heads, or heads, tails, tails. These are the 3 different ways I can get 2 tails and 1 heads. This is an event from my sample space. An event is noted by usually a capital letter. So for instance, calling get 2 tails, we'll call it event A. And the probability of A is denoted as P parenthesis A. the probability of A. Okay, probability rules. The probability of any event is always between 0 and 1, so 0% to 100%. A probability of 0 means it never occurs, and probability of 1 means it always occurs. The reason I mention these, because this is really obvious, is let's say problem A, you have no idea. Then problem B, you know, but it says based on problem A, ...
Arcadius, if you're in the building, can you please come to the AP office? Arcadius, if you're in the building, please come to the AP office. Thank you.
So it says based on A, then show whatever. And let's say you understand how to show whatever if you knew what A was. So what I want you to make sure you do is I want you to guess something reasonable. When I say something reasonable, if I said, okay, this was something, 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 I ask for what the probability of A is, and you don't know, you better not put like 2.5. It has to be between 0 and 1. Because if you put something unreasonable, I can't give you any credit for B. But if you put something reasonable, and obviously it's a guess because you have no idea, because you're just guessing, because you're like, I have no clue, I'm just going to guess, let's say 0.3. And you're going to get that wrong because it's not, you don't know how to do it. But you can get this 100% right if you show your work, even though this is a wrong answer, if you show the correct work for part B using part A's incorrect answer. So, of course, this is 0 and 1. Now, if S is the sample space, that was all this. Remember rolling a dice? So if S is considered the sample space, the probability of the sample space is equal to 1. That means that one of these events will happen. This is the something is going to happen rule. Now, the probability that event A does not occur is 1 minus the probability that it does occur. This is called the complement of A and is denoted as this, PA with a C up here or PA prime. So you can call this PA prime. And that's just 1 minus the probability that it occurs. So for instance, the event A could be raining. So the probability, the complement of A is not raining. So the probability of A, let's say I got a 70% chance of raining. That means the complement is I have a 30% chance of not raining. When flipping 2 coins, the probability of getting 2 heads is 25%. The probability of not getting 2 heads is just going to be 1 minus 0.25, which is 0.75. If the events have nothing in common, we call them disjoint. Think about the word. If your shoulder is out of joint, dis means out of or not in, and so it is not together. We also call this mutually exclusive, is going to be the other word for you. The way I'm going to draw disjoint is this. Oh, I didn't draw a complement for you. Let me jump back here and just draw a complement. Complement is this. Let's draw. This is A. This is B. And so they have the probability, so the probability of A plus the probability of B is equal to 1. Or let me just note it as A and not A, because that's really what it is. So the probability of A and the probability of not A is equal to 1. All right, so back down to disjoint. So disjoint, I'm going to draw it like this. I've got a circle here. I'm going to just change colors. Got a circle here. And I've got a circle, let's do this here. Okay, we're going to call this C. I'll call this A. And I'll call this B. Now, B are disjoint because there's no outcomes in common. A and B are disjoint because they have no overlap. All right, I'm going to give you a little bit of example here. Let's say that the event A represents, let's say A represents owning one dog. Let's say B represents owning two dogs, like exactly two dogs, exactly one dog. And C represents owning a cat. So if I ask you, I ask a class of 30 people, let's say 10 out of 30 own one dog. Let's say 5 out of 30 own two dogs. And let's say 15 out of 30 own a cat. Now that means I've got some overlap here of the cat. So then, let's say we have, let's say I'm going to have 6 out of 30 own none. So that would be 6 out of 30 over here, which is none. Now I know 15 out of 30, I don't know where the overlap is. I do know that I've got some overlap, obviously, because this is 6 out of 30 here, and I've got to add it all up to 30 out of 30. So I have to make sure that I don't have too much, because I clearly have an overlap, because I've got a cat and a dog, and I haven't been given that information. I don't have enough information in this particular Venn diagram to be able to solve it. But the main thing that I'm wanting you to see right now is that having one dog and having two dogs are completely disjoint, because if I say this is exactly one dog, how many own exactly one dog? What's the probability of owning exactly two dogs? These are disjoint because I can't own exactly one dog and exactly two dogs at the same time. Now, cat owners, I can own a cat and one dog. I can own a cat and two dogs. I can own a cat. This part here represents oh, that's really large. This part here represents, a cat and no dogs. So this yellow part's a cat and no dogs. This part here, this orange part, is a cat and one dog, and this part here is a cat and two dogs. This red part here is one dog and no cats. This blue part here, oh, I already have a blue part. Let's go hot pink. This hot pink part here, two dogs and no cats. And then let's go with green, but larger. Might be too large. We'll say, yeah, a little bit. The rest of the area, not supposed to be outside of it, means no dogs. Or it could be 3 dogs, right? Because it could be 3 or more dogs and no cats. So that's what the area outside means. Okay, but disjoint. So disjoint here is probability of A or B, and that means if I say, what's the probability of owning a one dog or owning two dogs? So that's going to be the probability of A plus the probability of B. I'm able to add them because they're disjoint, and so for mine, this would be 10 out of 30 plus 5 out of 30, so it's going to be 15 out of 30. So in my sample size, this is the probability of owning one dog or two dogs. This is disjoint. So let's jump back up to complement. Do you notice that complement, if you're a complement, you are definitely disjoint. So a complement, an event, and its complement are disjoint. Always. Because they never have an event in common. Remember, disjoint means there's an event in common. But disjoint events are not always complements. This particular one we did are not complements. One dog is not the opposite of having two dogs. Owning a dog and not owning a dog are complements. There's another complement that I have in here. Notice this yellow, this C, this part shaded here. That's owning a cat. All the green part shaded over here is not a cat. Or I guess if I continued on the green part as well, the whole thing. That would be cat, not a cat. Those would be a complement, and those are disjoint. Okay, so this one is rolling a die on an even number, which would be 2, 4, 6. Rolling a die on an odd number, 1, 3, 5. So the probability of A or B would be 3/6 plus 3/6 equals 1. So just like I did up here, just like down here, please show your work. Okay, so we have complement. All complements are disjoint because they never have anything in common. We have disjoint, and that's two events that do not have something in common, which that's mutually exclusive. Okay, and now this next one is going to be independent. Now, two independent events. An event is independent if it does not affect the outcome of the other. So let's look at this. Roll a yellow die and a red die. Event A landing on an even number and B landing on an odd number. Can I land on an even number and can I land on an odd number? Can both of them occur? The probability of this occurring is 1/2. The probability of this occurring is 1/2. Can both of them occur? Sure they can. So let's draw what independent is. Now look, this can occur and this can occur, or they can both occur. That's what independent is, but independent has a special relationship. I'm going to talk about that in a second. Remember, it doesn't matter. If I'm rolling a die, here I have a dice, right? And I'm rolling it, and I get it looks like I got a 2 up there. And then I have another dice. It's not going to affect, I'm not going to be affected of what I get based on what my first dice gets. So if this is a 3 and this is a 1, they don't affect each other. They're independent. It doesn't matter what I get. So here are the special aspects of independence. The special aspects of independence, let's just do this one. Let's say I have two events are independent, A and B. And let's say I'm telling you A and B are independent. If A and B are independent, this is the special relationship. Then if I say, let's say the probability of A is 20%. The probability of B is, let's say, 30%. Then the probability of A and B, which, guys, is the overlap, this part right here, is going to be 0.2 times 0.3, which is 0.06. So if I'm going to go ahead and make this Venn diagram, I have 0.06. Now this part, remember part A, that's 0.2 for the entire circle. So that means for the entire circle. But I just want this part as just A. So that'd be 0.2 minus 0.06, which is 0.14. Then for B, remember the entire circle for B is 0.3. But I don't want the entire circle because I have to subtract that overlap. So this would be 0.24. So if I ask you to make this Venn diagram, this then would say, okay, this is 0.14 plus 0.06 plus 0.24, and that is equal to 0.44. So the one that is not occurring is going to be 0.56, so that goes right here, because this represents none. The probability of A and B, or A or B not occurring. So remember, this is only when they're independent can I multiply them. If they're not independent, I have to be given that information. I have to be given more information. But if they're independent, all I have to know is, number one, they're independent, and number two, I have to know what the probabilities are, and then I multiply them. So for this one, it says the probability, what's the probability that a yellow die lands on an even number? What's that probability? 1/2. And the red die lands on an odd number, and that's also 1/2. So that's going to be 1/2 times 1/2 equals 1/4. Let me take a side real fast and remind you what these symbols mean and what they mean. So you guys probably remember, or if you don't, U is my OR, and it's union. And that's if I have this one and this one, it's my entire space. This one is and this is the way I do it. I try to do it like this, so I can remember it. And that just means my intersection. Here and here, and it's just that overlap right there. Okay, and remember, I said if the events A and B are independent, their complements are also independent, and this is independent, they're all independent, everything's independent. If we know it's independent, it's independent. The probability, okay, so the next part. The probability that an event occurs, knowing another one is called conditional. So this is here, the conditional probability is noted as PA given B. This means the probability of A given B is for sure. We know 100% for sure that B has occurred. 100%. We got it. So I'm saying, okay, what's the probability of A given B? So let me just do a really quick example here. Let's just do, we kind of did some of these at the very beginning of school. So I have A, B, and then let's do, let's say, well, here, let me just go. All right, let's say boy, girl, cat, dog. 5, 10, let's see, 20, 30, 25, 40. Okay, if I said, what's the probability of being a boy given I own a dog? Given I own a dog means I only want to know about the boys who own dogs. I only want, given means I know it's occurred. This person that I'm asking for you to choose owns a dog, period. So I want to know the probability of the boy, of it being, of this person being a boy. So it'd be the 10 over the 40. Okay, so that's how you do, remember, that's how you do conditional probability. Now, we have a special probability, because here we go, if the events are independent, if the events are conditional, then watch this. Let me give you first of all, the equation for probability of A given B. The probability of A given B, this is given in your formula chart, A and B over probability of B. And this one you don't have to memorize because this here is given to you on your formula chart. So let's go ahead and write that out. But this is if these are independent. If A and B are independent, I have a special case because let's go look back at this one here that we just did. Come back here, scroll back, and wait a minute. We just did this one. Probability A and B is the product. So can't I just write this? And if I write that, if you can see, you can go back to algebra class and cancel that, and you get, probability of A. And that makes sense because we already talked about that if A and B are independent, B does not affect A, whether it happened or whether it didn't happen. So the probability of A given B is equal to the probability of A if A and B are independent. And if I tell you to prove if A and B are independent or not, you must use this equation or you must use this equation, either one. You show those two equations, one of those two equations, and you will be able to get your result. And that will be sufficient for your proof. Okay, so let's go ahead and look here. If the events are, if when flipping a coin twice, what is the probability of getting a heads on the second flip if the first flip was a head? Okay, if the first flip was a head. So I'm looking for, if I say, okay, what do I know? So I can have heads, tails, because I know the second flip is a head. I can have heads, heads. Oh, I read it wrong, sorry. What's the probability of getting heads on the second flip if the first flip was a head? So let's try that again. So we could have tails on the first flip, or sorry, given. Heads have to be the first flip. So we can have tails or we can have heads. So these are my two choices, but I want to know, okay, this has to occur. Heads has to occur on the first flip. So it could either be this one or this one. So obviously this probability, I want to know this one here, which is a 50% probability. Well, that makes sense because that's a 50% probability anyway because they're independent. So this is 1/2. All right, so let's look at here. We have union, which I talked about already. And but both the events occurred. But remember, you're going to have to subtract the overlap. It's probability of A plus probability of B minus the probability of A or B. The union, this is the probability of two or more events that all occur, or all of them events. This here is intersection. Oh, sorry. Nope, I was thinking that went with that one. This is intersection. And that's just this intersection here. And that's probability of A plus the probability of B. Oh, addition rule. No, this is not supposed to be addition rule. That's the problem. This is supposed to be multiplication rule. So what we're going to do here for A and B is we're going to just derive this. By multiplying both sides by probability of B. And then you'll get probability of A and B is the probability of B times the probability of A and B. Okay, let's go ahead and look at this. I have 36 students. 25 likes to listen to rap, so 25 out of 36. Alternative is 22 out of 36. Rap or alternative is going to be 25 out of 36 plus 22 out of 36 minus the and. And so the and oh, it tells me right here, 16 out of 36. Now, when you're doing a Venn diagram, we're going to always start with the overlap. So A is going to be, remember, 25 minus that 36. So that's going to be 9 out of 36. And this here is going to be 6 out of 36. Now, if I add them all up, I get 9 plus 6 which is 25 plus another 6, which is 31. So this leftover is 5 out of 36, and that are none. The complement of A is just 1 minus 25 out of 36, because A, remember, was 25 out of 36. And then complement of B, 1 minus 22 out of 36. So the complement of A means not A. So literally means not A. Or not B. So not B would be so literally all I do is just, it's all of the shaded areas, so just 1 minus that 16 out of 36 that I've got here. So it's just 1 minus the overlap because I'm asking for everything that's the opposite. So for the next one, not A and not B. So not A. So this one here, let me just use a little bit more transparent colors for this one. So not A, because this is going to be an overlap. And not B, so I'm looking for the overlap area. So and not B. So it's just kind of this darker shaded area. So that would be, I get the 5 out of 36. So it's just that overlap area. That's it. All right. Formulas to memorize. These are on the chart, and you do not have to memorize them. This is the probability of A and B, is the probability of A and B. Sorry, A given B. This is on the chart, and you don't have to memorize it. And the other one that's on the chart that we just did that you don't have to memorize is the probability of A or B, and that's the probability of A plus B minus the overlap. The ones you do have to know by heart, I say know by heart because I want you to have this not really memorized. I need you to know the concepts. If they're independent, the probability of A and B is equal to the product of A times B, the probability of A and B, or the probability of A given B is equal to probability of A, or complement or anything else. And then finally, if they're disjoint, the probability of A and B is 0 because there's no overlap. And the probability of A or B is just the probability of A plus the probability of B. Okay, remember, I'm giving you extra credit on your Math Excel this time if you show all your work. So when you do your Math Excel, I'm going to have you on paper show all your work. If it's not something you show work for, just give me the explanation. And then I'll have you upload it on Canvas, and I'll give you an extra 10 points per Math Excel if you go ahead and do that. All right, thank you so much.